Hello students, in the last lecture I discussed about STAX RP instruction of 8085 microprocessor. I told you what does STAX RP do. It stores the content of accumulator into the address into the memory location whose address is mentioned by the register pair. So the next instruction that I'm going to discuss in this lecture is LDAX RP. It is just the opposite of STAX RP. What does LDAX RP do? It stores the content of memory location whose address is specified by the register pair into the accumulator. Again, I am repeating. For example, let us take an example. LDAX. Let us suppose LDAX. Let the register pair here I am taking is HL register pair. So I will mention H here, the higher byte register. So what does this instruction do? Suppose at the time of execution of this instruction, let the content of HL register pair is 4030H, and this is the memory location, and let the content of memory location whose address is 4030H, let it be 48H. So what does this instruction will do? After execution of this instruction, it will store the content of memory location. It will store the content of memory location whose address is specified by the register pair. So here the address which is specified by the register pair is 4030H, and the content of 4030 is 48H. So after execution of this instruction, accumulator's content will be 48H. Now again, since this is a data transfer group instruction and no arithmetic or logical operation is involved, so the flags affected will be no flags will get affected. Here I have written also no flags will get affected. Now number of bytes of the instruction, again, since there is no extra hexadecimal number mentioned in the instruction, it is LDAX RP and no hexadecimal number is mentioned in the instruction. So this instruction is of only 1 byte. That is, when this instruction is stored in the memory location, then it will occupy only one memory location, and that memory location is only for opcode of this instruction. Now, how many machine cycles is needed? Again, let me just draw the memory location. Suppose C000H is the starting address, and when you are giving this instruction is getting stored in the memory location like since this instruction is only 1 byte and that is opcode, so only the opcode of this instruction will get stored in the memory location. Now for execution of this instruction, what microprocessor will do? It will first fetch the opcode of the instruction. Microprocessor will first fetch the opcode of the instruction and decode it. Now after decoding, microprocessor will get to know that it has to store the content of memory location into the accumulator, and which memory location whose address is specified by the register pair. So the address is already present within the microprocessor because it is the content of register pair which is inside the microprocessor. So second machine cycle will be used by microprocessor for reading the content of the memory location and storing it into the accumulator. So all total 2 machine cycles is used for the complete execution of this instruction. That is, first machine cycle for opcode fetch and the second machine cycle for memory read. Now T states, how many T states are needed? Since opcode fetch machine cycle has 4 T states and memory read requires 3 T states, so all total 7 T states will be used for the complete execution of this instruction. Now again, what is the addressing mode? Since here, as you can see, LDAX RP, the operand, what is happening here, the operand's address is indirectly specified by the register pair So this type of instruction will have register indirect addressing mode. Now the next instruction is, so the next instruction is XCHG. Okay, the next instruction is XCHG. What does this instruction do? Suppose at the time of the execution of this instruction, the content of H is 30H, the content of L is 28H, the content of register D is 40H, the content of register E is 36H. Suppose. So after execution of this instruction XCHG, the content of H and the content of D will get interchanged, and the content of L and the content of E will get interchanged. So after execution of this instruction, what will happen? H will have the content 40H, D will have the content 30H, that is the contents are being interchanged between H and D, and L will have the content 36H, and E will have the content 20H. So here what is happening? The content of the register pairs H, L and D, E are getting interchanged. So here I have written also XCHG. What does this instruction do? It exchanges the content of the register H with that of D, and of L with that of E. Now how many flags? Again, this is a data transfer group instruction. No arithmetic or logical operation is involved. So flags affected will be nil. No flags will get affected. Now number of bytes of the instruction. Since XCHG, no extra hexadecimal number is mentioned along with this instruction. So this instruction will have 1 byte, and that is opcode only. So how many machine cycles are needed for the execution of this instruction? Now as I have told you, let us take an example. Let us suppose this is the memory location. Suppose this is the address of the memory location, and when you are giving XCHG instruction to the microprocessor, it will get stored in the memory location in such a way that the opcode will get stored. And it is a just 1 byte instruction. It will occupy only one memory location. So that memory location is used for storing the opcode of the instruction. Now what will happen? At the time of when the microprocessor is going to execute this instruction, first machine cycle will be used for fetching the opcode of the instruction and decoding it. So once the opcode is being fetched and decoded, what will happen? Microprocessor will get to know it has to exchange the content of HL register pair with that of D register pair. Since HL and D register pair are present inside the microprocessor, so in the one machine cycle only the whole instruction will get executed. That microprocessor will not need any extra machine cycle, that is memory read or memory write machine cycles, or input output read or input output write machine cycles for the complete execution. So only one machine cycle, that is opcode fetch machine cycle, will be used by the microprocessor for the complete execution of this instruction, as all the required data are already present in the microprocessor. So opcode fetch machine cycle. Now how many T states? Since opcode fetch machine cycle has 4 T states, so this instruction will need only 4 T states. So what is the addressing mode of this instruction? Since here the operand is the content of register only, as you can see XCHG, what it does, it exchanges the content of HL register pair with that of DE register pair, and both HL and DE are registers only, and here the operand is the content of this register. So the addressing mode for this instruction is register addressing mode. So this was all about data transfer group instructions. So here the data transfer group instructions is complete. will continue further with the instruction set of 8085 microprocessor only, and will start the new group, that is arithmetic group, in my next lecture.